Welcome back, ladies and gentlemen. We are taking a look at our right triangles review for our upcoming test. So we'll get right into it, okay? Find the unknown side lengths, simplify answers that are radicals. So, if you are ever given two sides of a right triangle, you know you can rely on good old Pythagorean theorem, okay? A squared plus b squared equals c squared. The important thing to make note of is that c must be your hypotenuse. Okay, so please keep that in the back of your mind at all times. So when you're doing this, first thing I recommend doing is trying to label what your hypotenuse is. So there's my C. A and B are interchangeable, okay, so it's not necessarily the most important thing. And now we're ready to go. So we're looking at 6 squared plus 8 squared equals C squared, okay, or in this case x squared. All right, I'll put an x there so that we're okay. Now, using my calculator, 6 squared gives me 36, plus 64 equals x squared. If I combine 36 and 64 together, I get 100. Now the opposite of squaring something is to square root left and square root right. X equals 10. Okay, there you go. I don't have to simplify any radicals down. It's a perfect square, all is well. This is also known as a Pythagorean triple, okay, from a little throwback there, a 6, 8, 10. All right, part B. If I take a look here, my 13 is going to be my C, right? Here's an A, here's a B. Again, the hypotenuse is the hardest one. So up top here, I've got x squared plus 5 squared equals 13 squared. Okay, so we're looking at x squared plus 25 equals 169. I can subtract 25 from both sides. X squared equals 144. You may square root left and square root right. Your x is 12. So again, this is another Pythagorean triple. You got a 5, 12, 13. They're all rational numbers, okay? You're all good to go. Part C, 12 is going to be my C. So here's my A and my B. All right, you're looking at x squared plus 8 squared equals 12 squared. X squared plus 64 equals 144. Okay, gonna bring in the big guns here. Okay, so 144 minus 64 gives me square root of 80. Well, sorry, x squared equals 80. Square root left, square root right. Now you're trying to simplify these down, so I'm trying to find a perfect square that goes into it. 16 will go into it 5 times. The square root of 16 is 4. Okay, very nice. So this would not be a Pythagorean triple because you have 4 root 5, 8, and 12. There's a ton of Pythagorean theorem problems here. Please don't think you're going to have 6 of these on the test. All right, it's just giving you guys practice, getting you guys geared up for this test. Okay, so keep that in mind. Here's an A, here's a B, here's a C. Again, the hypotenuse is always across my right angle. So we're looking 4 squared plus 10 squared equals x squared. 16 plus 100 equals x squared. Okay. 116. The opposite of squaring is to square root. So for 116, okay, we can have the perfect square of 4 go into it. Root 4 times root 29. And the square root of 4 is 2. Wonderful. Okay, and again, not a Pythagorean triple because my hypotenuse is 2 root 29. All right, much the same. A, B, C. X squared plus 9 squared equals 15 squared. Okay. X squared plus 81 equals 225. 225 minus 81 gives you 144. So x squared equals 144. If I square root this, this is a perfect square. Okay, and again, how I show that is this second square root. 144, close it. 12. So x equals 12. If asked, this would be a Pythagorean triple, 9, 12, 15. And finally, 5, 8, and x. X is my c, here's my a and my b. We're looking 5 squared plus 8 squared equals x squared. 25 plus 64 equals x squared. If I add them together, I get 89. Square root left and square root right. Okay. You can try, I believe 89 is prime, almost positive it is, and there's nothing that can go into it, therefore my answer is just square root of 89. I can't break it down any more than it already is. Okay, and that again would not be a Pythagorean triple. Okay, wonderful. So just a lot of Pythagorean theorem there. Get comfortable with it. There is a fair amount of problems in the test with that, but you guys should be cool with labeling the hypotenuse, okay, in each of these problems, and then just running your Pythagorean theorem. Okay? Good. Number 2, given the following 3 sides of a triangle, classify the triangle as right, acute, or obtuse. All right. This is the one where I'm going to put this at the top of your page. If I have a squared plus b squared equals c squared, I know I have a right triangle. Okay? If a squared plus b squared is greater than c squared, if the smaller sides win, then it's an acute triangle. Okay? And then over here, I'm sorry, I apologize for that. I hope you didn't have your volume up high. All right, a squared plus b squared is less than c squared. If your biggest side wins, then you have an obtuse triangle. All right, so you do need to know those 3 basic properties. Everyone's cool with this one because you guys have been running Pythagorean theorem for a while. These 2 are the ones that just take a little while to get used to. Okay, so I recommend jotting these down as soon as you get your test. So the hardest part about all of these is you have to pick the largest side. Okay, the largest side is just the biggest number, c. And I'm just basically running Pythagorean theorem to see what my outcome is. 5 squared plus 12 squared, see if it equals 13 squared. So we're looking 25 plus 144. Does that equal 169? In fact, it does. So because 169 equals 169, this would be a right triangle. Okay? Nice. All right, over here, the square root of 8 is a little less than the square root of 9. Okay, the square root of 9 is 3, so my largest side is going to be 6. Root 8 squared plus 4 squared equals 6 squared, possibly. I'm not sure yet. Guys, check this out. When you square a square root, so the square root of 8 squared, you get the number underneath it. Okay? As we talked about in class, when you root 8 times root 8, you get square root of 64. It's a perfect square. So that gives me 8 plus 16, and I'm trying to see if that equals 36. Well, 8 plus 16 is 24. Okay? 24 is less than 36. So my a squared plus b squared is tinier than c squared. Right there. Oh, I'm sorry. Okay, obtuse. Pointing at the wrong thing. Obtuse triangle. Okay, wonderful. Now, part C, A, B, C, here's my C. 20 squared plus 21 squared, see if it equals 28 squared. Okay. I'm going to have my calculator help me out big time for this one. 20 squared, 21 squared, 28 squared. So we're looking 400 plus 441. See if it equals 784. 841, 784. This time the a squared plus b squared is larger. Because that is, this would be the acute triangle problem. Okay. And finally, I've got my A, B, C. If you're wondering about, even though 13 looks bigger than 10, 12, it's the square root of 13. So it's actually somewhere between 3 and 4. So 3 point something, straight up because square root of 9 is 3, square root of 16 is 4. Nice. So C is my 12. Root 13 squared plus 10 squared. See if that equals 12 squared. You're looking 13 plus 100. See if that equals 144. It will not. 113 is less than 144. Because my c squared is larger, this would be an obtuse triangle. Okay, nice. All right. We'll do this last three here, right here, and then we'll save for part two the rest of it. Use properties of special right triangles to find missing side lengths. Okay. So you want to first identify, this is a 45, 45, 90 triangle. Okay. So I know the ratio is x root 2 here, and it's x root 2 only for a 45, 45, 90. It wouldn't be x root 2 if it was 30, 60, 90. It's only going to be an x root 2 if it's 45, 45, 90. I should just make a video of me just saying that over and over again. So across from 45 is x root 2. Okay? So this is x. Ooh, we get lucky here. X equals 10. Okay? So that means this has to be 10. And then over here, this is just, you plug it into your ratio, 10 root 2. Okay? So again, x root 2, 10 root 2. You're all good. I'm actually going to pause right here. Okay, we'll pick up right here next video, just because I want to make sure I have plenty of time to say x root 2 again and again and again to drill it in your heads and have you hate me some more. Okay. As always, keep up the good work and good luck. We're all counting on you.